Okay, we have one more type of indeterminate form to learn about, and that's when we have what are called indeterminate powers, meaning we have 0 to the 0 or 1 to the infinity. So we're going to explore this by looking at the limit as x goes to 0 from the right of x to the x. And we see here if we plugged in 0, this is of the form 0 to the 0. So the first thing we're going to do is we're going to set up an equation and say we're going to let y be this limit that we're looking for. So y basically is our answer, what we're trying to get. But this allows us to have an equation where we can do something to both sides. So now that we have an equation, what we're going to do is we're going to take the natural log of both sides. So we'll have the natural log of y is equal to the natural log of the limit as x goes to 0 from the right of x to the x. And one of our limit laws actually says that we can switch the natural log and the limit. So we can say that the natural log of y is equal to the limit as x goes to 0 from the right of the natural log of x over x. So now we're going to use our logarithm rule, and we know that the natural log of x over x, we can bring this exponent down, and so we can rewrite this. We're going to keep both sides. So we have the natural log of y is equal to the limit as x goes to 0 from the right of x natural log of x. And now, if you look at plugging in 0, we now have the form 0 times negative infinity. And this is one of our indeterminate products. So we're going to follow it like we would that. And so if the next step doesn't quite make sense, please go back to the indeterminate product video. But we're going to rewrite the right-hand side as the natural log of y. Well, that's the left-hand side. We'll rewrite the right-hand side as natural log of x over x to the negative 1. And so just remember, if x to the negative 1 is in the denominator, it's the same thing as bringing it up to the numerator and making it a positive exponent. So these two things are equal. Now we have the case infinity over infinity, where we can directly apply L'Hopital's rule. So we're still going to have the natural log of y, and just keep that with you so you remember what you have, is equal to the limit as x goes to 0 from the right of 1 over x over negative x to the negative 2. Okay, so here's what we have. And if you take a minute and simplify what we're taking the limit of, 1 over x, this would be over negative, or 1 over x squared. So when we multiply by the reciprocal, we would multiply by negative x squared. Negative over 1. And so this whole, the right-hand side becomes the limit as x goes to 0 from the right of x, negative x. And we know that that limit is just equal to 0. Now, what we actually have here, that's not our final answer, we have that the natural log of y is equal to 0. Now, remember, y was going to be our answer. We want to solve for y. And what this means, what we can do is we can take e and raise both sides to e. So we can say that e to the natural log of y is equal to e to the 0. And now some of our logarithm exponent rules, e to the natural log of y is just y, or the limit that we were trying to solve for, and e to the 0 is 1. So our final answer here, what we're saying, that the limit as x goes to 0 from the right of x over x is equal to 1.